Hey guys, as promised, here is the video going through the Unit 6 through 8 test review homework. So just going to go through these, answering all the questions, starting with number 1. We have f of x as x cubed plus 1. What we want to think about for a, f of negative 2, all I'm going to do is plug in negative 2 everywhere that I have an x. So f of negative 2 is negative 2 cubed plus 1. Negative 2 cubed is negative 8. Negative 8 plus 1 is negative 7. For g of 8, I'm going to plug 8 into my g of x, which is the cube root of x. So g of 8 is the cube root of 8, which is 2. For f of g of x, I'm going to plug g of x into everywhere that I have an x for f of x. So f of g of x would be, well, in place of x, I'm going to put the cubed root of x. So that was my x for f of x. That gets cubed and has a 1 added to it. The cubed root of x cubed, those cube roots and cubes cancel, so I'm just left with x plus 1. F of g of negative 1, we've already calculated f of g of x, so all I'm going to do is plug negative 1 in for my x value here, which is 0. Finding the domains, we've got a couple instances here. When we have just a rational, we have x squared minus 9 in the denominator, we know that we can never have a 0 in the denominator. So I know that x squared minus 9 cannot equal 0. So x squared cannot equal 9. So x cannot equal the plus or minus the square root of 9, which I know is 3. So x cannot equal plus or minus 3. So with that, I have to write this in interval notation. So I know that from negative infinity until negative 3, the function exists. But at negative 3, I cannot have the function. It doesn't exist at that point. So I have a break at negative 3. But then again from negative 3 to 3, and then again from 3 to infinity. So we indicate these breaks here, parentheses. That means it does not include negative 3 or 3. For the square root of 5 minus x, I know that I can never have the square root of a negative number. So I could have the square root of 0 in this case here. So 5 minus x has to be greater than or equal to 0. So 5 has to be greater than or equal to x, if I added x to both sides. So this is flip-flop from what we're used to seeing. We're used to seeing it as x would be less than or equal to 5. So we know that the function exists from negative infinity all the way up until 5. Question number 4, we see the x minus 2 under the radical also in the denominator. So I know that I cannot have a 0 under here. I cannot have this radical be 0, because then I would have a 0 in my denominator, and I know with a rational function like that does not work. So x minus 2 has to just be greater than 0. The difference between these two, greater than or equal to, and just greater than. So x must be greater than 2. Which means the function exists from 2 until infinity. Bracket here for 5 because greater than or less than or equal to, just a parenthesis here for 2 because just greater than 2. For 5 and 6, we want to look at the graph. We want to determine if the function is of odd or even degree and if the leading coefficient is positive or negative. The positive or negative leading coefficient is determined by the end behavior on the right side. If we're going up towards positive infinity on the right side of the equation, we have a positive leading coefficient. Here for number 6, we see we're going down on the right side, so we have a negative leading coefficient. The odd or even indicates whether or not the two endpoints or end behavior is doing the same thing. So here we notice on the left it's going down, on the right it's going up. For number 6, they're both going down. So on the left and right, they're both going down. They do the same thing for even degree, and they do opposite things for odd degrees. All right, for number 7, we want to write the quadratic equation in vertex form, if it's not already in vertex form, and in this case it's not, this is polynomial form. Once we have that, finding the vertex will be much easier. So to find vertex form, we have x squared minus 2x plus a blank value, move that 3 over, subtract that value that we're adding. So the value that goes into this blank is b divided by 2 squared, where our b value is -2. Negative 2 divided by 2 squared is 1. So I'm adding and subtracting 1. So this portion right here is now factorable. So the purpose of this portion here was so that we could create something that could be factored. X squared minus 2x plus 1 is the same thing as x minus 1 times x minus 1, or x minus 1 squared. Positive 3 minus 1 is positive 2. So our vertex is 1, 2. We can plot 1, 2 on our graph to the right here and work our way towards finding the x-intercept. To find the x-intercept, we set our y values equal to 0, x squared minus 2x plus 3. Our first attempt, or what we should think of trying first, is seeing if this is factorable. If it is not, we're going to have to do the quadratic equation. So I'm going to think about two numbers that multiply to 3 and add to negative 2, and I'm going to find that I can't come up with anything that does that. So I have to use the quadratic equation. Negative b, which would be 2, plus or minus the square root of b squared, 2 squared is 4, minus 4 times a times c, all over 2a, and a in this case is 1. Going through and simplifying, we've got 2 plus or minus 4 minus 12 underneath the radical, all over 2. So already this is telling me that I'm going to have a negative under my square root, which is going to give me an imaginary number, so I'm not going to have a real root. I'm not going to have a real x-intercept here. So I can already stop and say none. To show you how we would continue simplifying this just in case we did want to find the imaginary 0, we would say this is 2 plus or minus the square root of negative 8 all over 2. With that negative radical, we can pull out I, an imaginary number. So I'm going to move over here. So 2 plus or minus I square root 8 over 2. The square root of 8 we can simplify as well. So 2 plus or minus 2I root 2 all over 2. So 2 root 2 is the simplified radical of square root of I. So 2 root 2. We can simplify this one step further. The 2 here and the 2i here breaks down into 1 plus or minus I radical 2. Those would be the imaginary roots, but for our x-intercepts, it doesn't ever exist, so there are none. For our y-intercepts, we set all of our x values equal to 0, and we're left with 3, so y equals 3. And we want to write this out as a coordinate point, so 0, 3, not as a line, y equals 3. So 0, 3. I'm going to identify the fact that I know this is going to be a parabola based on the given statement, graph the parabola. Additionally, I know that this is the vertex here, 1, 2. So if to the left I'm going up, and I also see that I have even degree and it's positive, so I know that it's going to do the same thing on either end. Even degree tells me originally it's going up on the right side. Positive, doing the same thing. Well, I know it's a parabola. This is my vertex, so this is the general form of my graph. Moving on to the back. Finding zeros. So our possibilities are just factoring, either by just factoring a quadratic or factoring by grouping, or we can find the zeros using the quadratic. Or we've got our P's and Q's, or we're given a 0 already. A couple different things that we can try. So looking at number 8, the first thing we always want to attempt is think, okay, can I factor this normally? We've got x squared plus 2x plus 9. Are there two numbers that multiply to 9 and add? No. So I have to use the quadratic equation. So x is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I've got plus or minus 4 minus 36 all over 2, which is negative 2 plus or minus the square root of negative 32 all over 2. Okay, already I'm seeing I have a negative underneath my radical, which is going to tell me I have an imaginary number. So I have negative 2 plus or minus. I'm going to simplify the square root of negative 32 by pulling out an I and simplifying the radical as well. So 4 radical 2 is the simplified radical for radical 32, but I have an imaginary coming out because of that negative 1. So 4i radical 2 is the same thing as the square root of 32. From there, we're going to simplify. We've also got divided by 2. We're going to simplify over here. Negative 2 over 2 is the same thing as negative 1. 4i over 2, I've got my plus or minus 2i, and it stays where it is. So this is the simplified version. As far as I can go, those are my zeros, those two imaginary zeros. For number 9, I want to try factoring. Well, I've got x to the 4th minus x squared minus 2. If I think about how I can factor this, my two first numbers have to multiply to x to the 4th, so that comes from x squared and x squared. And I want them to, the two numbers that I put in here, to multiply to negative 2 and add to negative 1. Well, that's going to be negative 2 and positive 1. So negative 2 and positive 1, if I were to go back and triple check FOIL, I would end up finding this exact answer here. Continuing on, I have to set each of these pieces equal to 0. So x squared minus 2, set that equal to 0. And x squared plus 1, and set that portion equal to 0. So I end up having x squared could equal 2, or x is plus or minus the square root of 2. Here, x squared equals negative 1, or x equals plus or minus the square root of negative 1. The square root of negative 1 we know is I, so x is plus or minus I. So we've got 4 possible zeros, plus or minus square root of 2, or plus or minus I. Number 10, we've got 4 pieces, and so we know that we can't factor it normally. Let's think about factoring by grouping. If I group these first 2 pieces together, could I pull something out where I would be left with the same thing if I pulled something out over here? Well, here I could pull out an x squared, and I would be left with x plus 5. Here, if I pulled out a 2, I would not be left with x plus 5. So factoring by grouping is not going to work for us here. So we're going to think about our p's and our q's. P's are the factors of the final term, so plus or minus 1, plus or minus 8, plus or minus 2, plus or minus 4. Factors of the leading coefficient, so plus or minus 1. P over Q is going to just be the same thing as P, because anything here divided by plus or minus 1 is going to give us the exact same values, so plus or minus 1, plus or minus 8, plus or minus 2, plus or minus 4. We want to pick a potential zero. So these are our possible zeros. We want to think about what we could potentially use to factor with synthetic division. I always start by trying negative 1 first, and I already know since I've done the problem that negative 1's not going to work, but I'll show you that my process of how I tried this. So I said negative 1, my leading coefficients for all of these terms, we've got 1, 5, 2, and negative 8. There's nothing missing. We've got a cubed, a squared, a to the 1 power, and to the 0 power, so everything's there. Bring down the 1, multiply. 5 minus 1 is 4, multiply, we got negative 4. Negative 4 plus 2 is negative 2, and then we multiply here, we get positive 2. So we end up having a remainder of negative 6. We know that if it was a 0, we would have a remainder of 0. So I went and then I tried negative 2 next. That was my next attempt. And I just picked that at random. So you just pick these zeros at random, and then you wait until you find the ones that do give you a 0 as your remainder. So I tried negative 2 next. So I have 1, 5, 2, and negative 8. Going through my synthetic division, you bring down the first term, then you multiply, then you add, then you multiply, then you add, and we end up having negative 2 times negative 4 at the end, which is positive 8, which when combined to the negative 8 gives you a 0. We can continue with synthetic division from here, but I can also rewrite this as x squared plus 3x minus 4, and I can factor this portion here. That the two terms must multiply to negative 4 and add to positive 3. The values that achieve that are positive 4 and negative 1. So I have zeros at negative 4 and at positive 1. Additionally, we can't forget the 0 at negative 2 that we guessed with at the beginning. So we have these 3 zeros as our final answer. All right, moving on to number 11. You are given a 0. So right off the bat, you know exactly what to put in your box for your synthetic division. Then we fill in, we've got 1x cubed, 2x squared, 4x, and 8. And we're going to go through with our synthetic division, bring down the 1, multiply. 2 plus 2i. From here, I want to multiply 2i by 2 plus 2i. So I'm going to do the work for that over to the side. Distribute the 2i, we get 4i. Distribute the 2i over here, we get plus 4i squared. We know that I squared is the same thing as negative 1. So in reality, I have negative 4 plus 4i. And I rewrote this to match with the standard form. So I fill in negative 4 plus 4i here, which works out nicely because when I add the 4 and negative 4 cancel, and we're just left with 4i. Multiply 2i by 4i, which is 8i squared. And again, we know that I squared is negative 1, so in reality we have negative 8 at this point. And as promised, f of 2i is 0. We do get a remainder of 0 here. Remember, whenever you have 2i or anything I, you also have the negative version. So negative 2i is also a 0 for us here. So I'm going to go through with my synthetic division, bring down the 1, multiply. Negative 2i and the 2i here cancel. We're just left with 2. 2i, or negative 2i times 2 is negative 4i, which cancels as well. And so we're just left with x plus 2 equals 0. Or x equals negative 2. So we've got 3 zeros. We have to remember the negative 2 that we just found, along with our plus or minus 2i that we had, even the one that was given to us in the beginning. We've got these 3 potential zeros, or these 3 actual zeros. All right, 2 more problems. Number 12, we want to solve the inequalities. First step is to move everything over to one side. So we need to get this 15 over. So I have x, and I'm going to distribute my x as well. X squared plus 2x minus 15. And the reason for that distribution is because I'm going to want to factor this. I want to find my possible, my points of inflection. I want to find my zeros. So I've got x squared plus 2x minus 15. This can be factored at x plus 5 and x minus 3. So I don't truly have a 0 because it's not equal to 0. It's going to be greater than 0. But my key points are negative 5 and positive 3. So those are the values that I'm going to use on my sign chart. So at negative 5 and at 3. I have to think about the behavior that's the values and less than the value and greater than the value. So anywhere on this sign chart. So at negative 6 will be a test value. Let's pick 0, that's between negative 5 and 3, and then let's pick 4. I'm going to take this negative 6 and plug it back into the factored versions. And all I care about is whether or not it's positive or negative. So negative 6 plus 5 is negative. Negative 6 minus 3 is negative. Well, a negative times a negative results in a positive. 0 plus 5 is positive. 0 minus 3 is negative. A positive times a negative is negative. Plugging in 4. 4 plus 5 is positive. 4 minus 3 is positive. A positive times a positive is a positive. And remembering at greater than or equal to, these are open circles. We want to consider where it is greater than 0, where we have positive values on our sign chart. That's happening here and here. So those are the 2 intervals that we care about. So from negative infinity until negative 5, close it with a parenthesis. And then again from 3 until positive infinity. When we have an inequality that also has a fraction, so a rational inequality, we have to also consider the vertical asymptotes. And that's the same thing. You set your denominator equal to 0. So what I'm going to do before I even think about that, I'm going to factor my numerator. And I'm going to see that I have x plus 4 and x plus 1 all over x minus 1 is less than or equal to 0. Nothing cancels, so we don't have any holes. What I'm going to do now is find the vertical asymptote, and that is at x equals 1. I set my denominator equal to 0. Finding my zeros, or my x-intercepts, I set my numerator equal to 0, so I have x is negative 4 and negative 1. And those are my key values that I'm going to use on my sign chart. Negative 4, negative 1, and 1. Negative 4 and negative 1 have closed circles, and then at x equals 1, that's a vertical asymptote. So I'm going to draw a dotted line. That's going to mean a parenthesis at this point. my key points are my test values. I've got -5, between -1 and -4, let's try -2, between 1 and 1, always try 0, and greater than 1, let's try 2. I'm going to plug these test points back into the factored version, and I only again care about whether it's positive or negative. So -5 plus 4 is negative. -5 plus 1 is negative. -5 minus 1 is negative. So here I have a negative times a negative is a positive. A positive over a negative is a negative. At -2, -2 plus 4 is positive. -2 plus 1 is negative. All over -2 minus 1 is negative. Negative times a negative is, or positive times negative is negative. Negative over negative is positive. So if negatives, it's negative. If it's an even number of negatives, it's even or positive. Okay. 0 plus 4 is positive. 0 plus 1 is positive. 1 is negative. Positive times a positive, positive divided by negative is negative. 2 plus 4, we've got positive. 2 plus 1 is positive. 2 minus 1 is positive. Positive times a positive is positive, over positive is positive. So again, the intervals that I'm concerned with are where it's less than or equal to 0. So we're looking for where it is negative. It's negative here and here. So my intervals for this would be from -infinity until -4 with a bracket because it's a closed circle. Again, from -1 until 1, bracket with -1, parenthesis with 1. Okay, and that concludes everything for this video. Hopefully you are able to understand all of these problems. If not, just shoot me an email.